Hi all, welcome to my course on ozone technology. This will be session 20B of the course, and it will be we will be discussing on the saltwater chlorination, pros and cons, corrosion and scaling, batherload, and turnover. So far we have been aware of the fact that when we deal with chlorine in a swimming pool, we normally add a specific amount of chlorine manually or by means of a pump. The amount of chlorine added will be dependent upon the concentration of chlorine in the pool. We have to, as far as specifications go, council specification state we should have at least 1 ppm of chlorine for domestic pools and between 1.5 to 3 ppm for commercial pools, depending whether they are internal or indoor or outdoor, winter or summer. Commercial pools can manage to add chlorine as a chlorine gas, which would be very convenient, and because of the high concentration of chlorine in there, only a small amount of gas is to be put into the water and the pH controlled by a pH meter. However, in the case of domestic pools, sometimes it may be very difficult to control the addition of chlorine or liquid chlorine. There are specific pumps available, and addition of chlorine can be controlled by the redox meter. There is, of course, another method of chlorinating the pool by using saltwater chlorination. Instead of having to add chlorine regularly, the pool is what salt is added to the pool to a specific concentration, and it goes through a series of electrodes which will electrolyze the chlorine, sodium chloride, to form chlorine, which then dissolves into the water and is sent into the pool. The amount of chlorination is controlled by the redox system. The chlorine is obtained from the sodium chloride that is added in the swimming pool. When the chlorine is depleted, quite obviously what's left over will be the sodium hydroxide, which turns the water alkaline, and therefore it may be necessary for us to add some sodium bicarbonate or a mild alkali in order to balance the pool. You would note that in all chlorinated pools, chemical treated pools, the balancing of the water, chemical balancing of the water, is very important. We have already discussed with the various requirements for the chemical balance, so that the chlorine that comes out either through the electrodes or addition is free chlorine and able to disinfect the water. Swimming in the salt water gives the feeling of swimming in the sea. We can discuss how chlorine is generated by the saltwater chlorinator. A small current is passed between two electrodes in the salt water, where the electrodes will form hydrogen and nascent oxygen that will oxidize the chloride to chlorine to form the active chlorine, which get used up for oxidation. The water slowly becomes alkaline from the addition of sodium chloride and the removal of the chlorine for the reactions and evaporation, and frequently has to be acidified so that the pH is maintained below 7.8, so that active chlorine is present. Salt is depleted over time and it must be replenished. The current used in electrolysis is at very low voltage that will not cause electric shock. The chlorination is controlled by time and also by redox or by by meters, which will detect the amount of current that is flowing and the ability for the chlorination. This is a schematic diagram of a typical saltwater chlorinated pool. The water, to normal fresh water, salt is added to a certain concentration specified by the manufacturer of the saltwater chlorinator. As the water is sucked through the circulation pump, it passes through the filter and it goes up. One section of water will go up and passes through the electrolysis cell, and this is the way the electrodes are present, and electric current, a DC power source, is given where the electrolysis of the sodium chloride is taken, where hydrogen and chlorine is generated. Then the chlorine goes back into the swimming pool and disinfects the pool. This process of saltwater chlorination may take place for a number of hours per day. It may be up to 8 hours, so that sufficient amount of chlorine is generated that is enough to disinfect the pool. As we have explained earlier, progressively the depletion of chlorine will cause the water to be alkaline, and it is necessary to ensure by frequent checking of the pH that it is maintained below 7.8, preferably at 7.2 to 7.3, and this is by addition of hydrochloric acid. So that will restore the pH as well as some chloride. We shall now discuss the pros and cons of chlorination against ozonation. The first issue of chlorine loss. Now when we add chlorine into the swimming pool, particularly during the daytime, 50% of the chlorine added will be dissipated because of the sunlight, which means the effective addition is only 50% of what you have added. So it is strongly recommended that chlorine is added in the night so that there is sufficient concentration of chlorine in the pool that will ensure total disinfection, so that by the morning, the pool is fit to be used. The amount of chlorine of the 50% that is left over, more than 90% of the remainder is used, of the chlorine that is remainder is used to react with the organics. So whatever the organics are in the water, that includes dissolved organics as well as possible suspended organics, it will form chloramines. What is left over is actually the residual. So when we add chlorine, we have to take into consideration a significant amount of chlorine is used up in reaction with the organics, so that we have to continue adding until we obtain at least 1 ppm for the domestic pool, 1.5 to 3 ppm for commercial pools. However, in the ozonation, the dissolved organics that the chlorine has to destroy or combine with will be destroyed by the ozone, which means more than the 95% of the net chlorine that has been added, which is used to break down or react with the organics, will be destroyed by ozone. And therefore, the amount of chlorine that you need to maintain the sanitation or disinfection is only about 5% of what you would add if it is chlorinated. In other words, if the pool is ozonated, the amount of chlorine that you add to maintain the 1 ppm will be very small compared to the amount that you have to add if it is a chemical treatment. The water becomes alkaline gradually as the chloride from the salt is converted to chlorine and used up to become a combination of organics, etc. And so we have to add hydrochloric acid to neutralize it and convert it back to sodium chloride. We have to monitor the pH to be at least about 7.2 to 7.3. We also have to ensure that we have sufficient chlorine up to the pH up to 1 ppm, so that the disinfection will be continued. So with ozonation, because the chlorine added will be very small, alkalinity does not increase, and there's no neutralization of water by any acid. Of course, when water is diluted by rain, we may have a dilution factor with respect to the chlorine, so we may have to add more chlorine to maintain the 1 ppm, but it will still be far less than if you use a chemical method. Further, we don't have to worry about the chemical balance when we use ozonation. The alkalinity will be very stable and pH will never exceed 7.8 because the final reaction of ozone with organics, etc., will be bicarbonate. And this bicarbonate solution, pH of that will be 7.8 and no more. We don't have the problem of sanitation. In other words, the pH, the sanitation by ozonation is not dependent on pH. So whether it is pH 6 or pH 7 or 8, the pH, the ozone will be very effective. But above pH of 8, we may have some issues with respect to the ozone, simply because the ozone is converted to free radicals that may not be good enough for bacterial kill. Therefore, it is necessary that we have to maintain the pH below 8. Because of the fact that no matter how much ozone you add into the water, the pH will never exceed 7.8. The question of pH disturbance will not arise. As I explained before in the previous slide, the chemical water balance is necessary with saltwater chlorination. Water balance means we have to make sure there is a specific alkalinity and also the pH between 7.2 to 7.5, but never above 7.8. With ozonation, we don't have to worry about the pH, and we don't have to worry about the chemistry, pool chemistry. With the chlorination, chlorine always reacts with the organics to form chloramines, which slowly build up over a period of time. Depends on the number of people using the pool. The more people who swim, the faster the chloramines are formed. These chloramines are toxic and they are carcinogenic, and therefore regularly superchlorination is required. Superchlorination is, of course, is a breakthrough chlorination where you increase the chlorine level of the pool to about 10 ppm so that the reaction of chloramines be reversed. With respect to ozonation, because ozone will react the organics, the added chlorine is available for sanitation and not formation of chloramines. However, if there are chloramines in the water, because, for example, it was used with chemical treatment prior, it is necessary to superchlorinate the pool to ensure that there is no more chloramines, and then proceed to ozonation, because ozone will not destroy or break up the chloramines, but ozone will prevent the formation of chloramines. With respect to chlorination, we have to service the chlorinator, or we have to manually service the chlorine equipment that doses the chlorine, or otherwise we have to manually add the chlorine every day. With respect to ozonation, service of the ozone generator may be required. That may be every 6 months or a year, only to remove dust and dirt that might be accumulated within the generator because of the suction of air by the fan that might bring in quite an amount of dust and other particles that may stick into the electronics and the ozone cell. When the pool is treated by chemicals like chlorine, as you would know that the dissolved organics are not removed completely, even though some of them will be removed by chlorine, either to precipitation or reaction, but the dissolved organics will continue, but they are like colloidal solutions that passes through the filter and comes back into the pool. And if you shine a torch into the pool, you can see the beam of light going to the floor. Once you see the beam of light going to the floor, it is a sign that there are lots of particles, dissolved organics, etc. in the pool that has not been removed. If the pool is treated by ozone, all the dissolved organics are flocculated and filtered off, so that if you shine a powerful torchlight onto the floor of the pool, you will find that you will not see the beam of light in the water, but only the light that is on the floor. The water will be absolutely clear. Proper management, pool chemistry management is important, because if the alkalinity is too low or too high, if it is too low, it will cause corrosion. If it is too high, it will cause scaling. So scaling or corrosion is always the factors that may cause problems with chemical treatment. In the case of ozone treatment, corrosion and scaling are not issues, simply because there is no increase of alkalinity and there is no decrease of pH because of ozone treatment. Therefore, the pool is safe from corrosion and scaling. There are two issues we must consider in swimming pool maintenance. The structure of the swimming pool is usually concrete or tiling, which is essentially a carbonate compound. So if the pH of the water is below 7, the wall surfaces of the pool would experience corrosion. It becomes pitted or rough, that enough to cause bruises. Therefore, the pH must be maintained above 7.2 or slightly alkaline. On the other hand, if the pH increases greater than 7.8, first of all, there will be no free chlorine as a biocide because most of the chlorine will be in combined form, which means the bacteria will not be killed. And there will be precipitation or scaling. This will also cause rough surfaces because of the scaling. Hence, maintenance of pH between 7.2 and 7.8 or more, appropriately 7.5, is critical. The total dissolved solids will increase over time but can be corrected when water is topped up for loss through evaporation and physical removal of bathers. Bather load is very important parameter, particularly to commercial pools. As domestic pools are used just by the owner, his family and friends, the bather load is generally insignificant. Bather loads, particularly children, tend to leak urine during the swim or play. It increases the urea levels of the pool, which decays to form ammonia. Bathers, particularly adult women, often use makeup and other cosmetics. They transfer these into the pool to increase the organic load. The organic load is dependent upon the bather load and the time of use. So if the bather load is high, the turnover and chlorine requirement is also high. This is used in the calculation of the turnover time. Turnover is increased when the bather load is increased or decreased when the bather load is decreased. Of course, we also have to add more biocides when the bather load is increased. With chlorinated pools, the higher bather load will increase the chloramines when we are using chlorine as a biocide. With ozone, there will be no formation of chloramines. So it is much safer to swim. There will be no smell on the hair or body or the clothes, and there will be less bleaching. We will also have to understand that when you get a chlorine smell in the pool, that chlorine smell is not because of chlorine in the pool, but rather the chloramines, because chlorine generally does not produce any smell. As I mentioned, turnover is also very important because we have to make sure that every ounce or every liter of swimming pool water is filtered through the filter so that all the particles, etc., are removed from the pool. There are specifications set down by the state health department or councils. The competition pools, 50-meter long, the turnover period between 3 to 4 hours. When it's meant by 3 to 4 hours, it means the whole 50-meter volume of pool must go through the pump between 3 to 4 hours. For conventional pools 25 meter long, the turnover period is 2.5 to 3 hours. For diving pool, it's 4 to 8 hours. Hydrotherapy pools, half to 1 hour. In other words, there is a very high turnover with hydrotherapy pools. Leisure water bubble pools, these are more like spas and hot tubs, etc. So the turnover is also fast, between 5 and 20 minutes, etc. So as we note, that we have to take into consideration turnover, whether or not it is chemically treated or ozone treated. So the pump, the strength of the pump, horsepower of the pump is determined by the amount of water in the pool, and how long the pool is to run in the day. So if the pool is to run 8 hours in the day, the pool has to turn over, say 3 to 4 hours within the 8 hours. That means it should go at least 2 or 3 times. We've come to this end of session 20B. Thank you very much for the patience of listening to my presentation. The next session 21A will discuss the significance of superchlorination, spas, jacuzzis, and therapeutic pools. And we will be introducing the application of ozone to swimming pools. If this is your first tune-in, please refer to sessions 1 and 2, which will provide the summary of topics that will be covered, and sessions 3 to 20 that will cover the course details. I will appreciate very much if you can tick the like and subscribe buttons, which will give me the satisfaction that my efforts to present the course free to all is producing results and is being watched by more people. And B, you will be notified of further presentation sessions as soon as they are uploaded. Thank you very much and have a pleasant day.